Okay, so this is chapter 17, Computable General Equilibrium. This will not be in the core exam, but it's good for you to know it because a lot of economists use it in real life and is an application of general equilibrium that you have studied. In general, it's nothing fancy in principle. So the real complexity of this is when you try to do it in real life, for real economists. In general, computable general equilibrium, CGE, is analysis of ex-ante policy evaluation. So you do it before policy happens. So we were talking last time that this means, for instance, you want to evaluate a free trade agreement. So it has never happened. You don't have data to evaluate it. So there is no way to know what's going to happen, right? So how are you going to do an evaluation of something that hasn't happened? Well, that's where structural models are useful. In principle, you build a model, right? And then you use this model to make predictions out of sample. And then you change parameters in the model that mimic the future policy that will be implemented, right? So imagine in a perfect world where you could actually do this in a good way, in a robust way, empirically sound way, then you could actually make, good policy recommendations, right? For people to choose what kind of trade agreement they want, for instance. Now, in reality, there are some issues with these models. In particular, they're going to be super heavy parameterized. Parametric forms in economics, even if they are widespread in applied economics, they don't have any theoretical, backing. So in particular, if you choose, for instance, a particular parameterization of utilities such as the Cobb-Douglas or CES, then essentially you are just jumping into you're opening a Pandora box. So you don't know what's going to happen. People do it because that's what people need in order to use these models given current technologies of modeling. So we're going to understand a simple model of 2x2 Ricardo Biner general equilibrium model. So this is a trade model. So Ricardo, the people that have studied some econ history, so he's essentially the second, most important economist, if not the most important economist, right after Adam Smith. Right, comparative advantage is thanks to him. And then, Biner, he's another, great international trade economy. And then basically, this is a very simple model trying to capture the economic forces that are at play in a 2x2 of a small open economy model. So if you remember your classes from undergrad, what is the idea when you study a small open economy? It's an economy that takes world prices as given, right? So you don't have any market power, and then essentially you take world prices as given. That's going to be the key signature of this thing. We're going to have two factors, production and labor. Labor is mobile across sectors, but capital is sector specific. And now you can see these equations. In particular, we're going to have some indexes that are going to index the different components of the economy. You're going to have industrial goods, agricultural goods, right? And then the total number of goods are number N. Houses are going to be indexed by HH. Time periods by TP. The parameters that I'm going to use in this economy is labor supply, total capital, production, constant elasticity of transformation, right? I'm going to explain this more as we go. Production, labor substitution, world prices. So remember, this is a small open economy. It takes as given the world prices. Then a shift in the parameter in the production function. So this is another parameter that helps you equate the production function to whatever data you have in the economy. So this will allow me to scale the production function to achieve a calibration of any output I observe in the data. As constant elasticity of substitution, share parameter alpha I, and then exchange rate. This is a small open economy, so there's going to be some world prices expressed in some monetary unit, and then you're going to have some exchange rate to change it to the local currency. For instance, Canada, the exchange rate will be the exchange rate of US dollars to Canadian dollars, right? So Canadian dollars to US. So you can transform world prices into the local ones. And then, as you can see, world prices multiplies by the exchange rate, we give you the local prices. So essentially, for instance, again, with example of Canada, you take as given, for instance, the price of some commodities like bananas, right? So there's going to be a world price, and then essentially you buy it, whatever is the world price in US dollars, multiply it by the exchange rate. Now, this is the equations. These are the equations of the general equilibrium model. So here is where, this is what people do even right now, to try to do modeling. So how do you choose these functions? Well, essentially, it's a bit of an art. So people try different specifications, and it's a balance between being more flexible, which can help to be realistic, and then having not a crazy model with thousands of parameters that you cannot calibrate. So the production function here is going to be what is called a constant elasticity of transformation. So the most well-known production function is usually the Cobb-Douglas, right? So everyone has used a Cobb-Douglas essentially in the Solow model. Here in this constant elasticity of transformation, what you have is that this is kind of the mirror image of the CES utility function, right? So it has the same properties. Essentially, there is a constant elasticity of transformation between the two inputs here, capital and labor, in order for it to produce an output of unit Q. Now, this is indexed by sector, right? As you can see here. So sub-I index the sector, right? So you have the industrial sector and you also have the agricultural sector. So these parameters are industry specific. Now you can see here that you have this share parameter alpha I that tells you the contributions of each labor or capital to the output, and then the constant elasticity of transformation, right? That gives you the shape of the production function, and the scale parameter, as I mentioned here, that will allow you to calibrate whatever the level of the production function to the observed output, right? So this A is a degree of freedom. Now, labor demand, this is coming from some utility maximization. Labor demand is from the first problem. This is the optimal input demand of labor, right? So labor demand here will be given by prices of the goods divided by the wage, multiplied by the share in the production function, multiplied by the scale, and then essentially this is multiplied by here the price again, and then with the share sigma multiplied by the output. So this equation again comes from the production function, and again it's nothing fancy, it's just a parameterization here. Important thing here, labor demand will be decreasing in the price of labor in wages, right? As wages increase, this labor demand will fall. Now, we are dealing with general equilibrium, so we have market clearing condition. So that means that the total labor demand across sectors, right, will be equal to the total labor supply. Here, labor supply is completely mobile across sectors, right? That means that the market clearing will happen, at the aggregate across sectors, right? And then labor supply here is inelastic. So it doesn't matter if you like to work or not, everyone works at level L superbar, right? Superline, overline. So in that sense, labor supply is inelastic and labor demand is elastic and changes with wages in an inverse relation, right? Now, capital is sector specific, so that means that whatever the endowment of capital you have in each sector, you use it for that sector, right? So in that sense, capital is not mobile, so you cannot move machines that produce agricultural goods like shoes, right, to produce corn. That's the idea here. So this is a kind of a simplified market clearing. So when you have mobility of factors, then essentially this changes the market clearing equations. Now, wage income. So remember that when you obtain income in general equilibrium, income is always endogenous, right? So here what you're doing is multiplying whatever labor demand you get, right? And multiply it by wages. And then you obtain endogenous income, right? So in that sense, this is general equilibrium because income is not given exogenously, right? It's formed in the economy. So this economy will find a wage, W, and then we'll give you a level of demand, LD, and then together they will form the income. So wage income. Now, as you can see, these individuals here, representative consumers or workers, can work across many sectors, right? Okay, because this is a summation across sectors. So they may use the labor supply across sectors. Remember that labor is mobile, right? So this, in principle, this equation allows you to work partial partially at the industrial sector and then at the agricultural sector. Then consumer demand. So consumer demand, again, here, this comes, you can recognize it easily that this comes from a Cobb-Douglas utility function, right? So this is you can see there is a fraction, and the numerator of the fraction has the household income divided by the price of the good, I, and then multiplied by a share. The share is beta H. So this share, that is a Cobb-Douglas utility function, is a household and good specific share, okay? So in that sense, it's a flexible Cobb-Douglas, but it's only a Cobb-Douglas. And this is essentially whatever households consume of the good I. Now, this is a small open economy, so we also have equations for imports. And essentially, this is how much you consume from the outside. Essentially, here a summation across households, and then how much is actually supplied. So the difference between what is demanded or consumed in this case minus what is supplied locally is the import equation, right? And the export equation is the same. So the excess between QS, which is supply, minus what is demanded of each good, will give you the exports, right? So whatever in this general equilibrium with an open economy, anything that is not consumed locally is sent abroad, and anything that you actually wanted to consume but is not supplied locally, then you import, right? And now you have a trade balance equation that essentially multiplies by the world prices, the imports minus the world prices times the exports, and this is equal to 0, okay? So essentially this will give you a balance equation, so there is no free goods, and this way you close the market, you close this economy. Okay, so important caveats here. So, all of these equations allow, our ancestors, right, our previous economists to be able to put this into a computer, put this into an equation, a regression that you can estimate, that you can calibrate, and then essentially you can map this to data from central banks or from local statistical agencies. And then the idea is to try to fit macro data using this parametric model. And then once you have fit this data, you can change parameters inside this thing. Like for instance, you can change the exchange rate, or you can add a tariff in the world price, or you can remove a tariff, right? So this model doesn't have a tariff now. So for instance, you can do a counterfactual trying to add a tariff, so introducing protections. Like for instance, Trump, you remember that he introduced tariffs to many goods, right? So steel from everywhere, right? So he wanted to protect the steel industry, and he was very random, but essentially he chose one sector and added a tariff to it. So you can, after you have matched your current economy with this model, then you can add counterfactuals, changing pieces of it. The classical changes, right, as I mentioned, is tariffs and small open economy model. The other classical one that people work a lot is on taxes. So you add an income tax tax scheme, sale taxes, you can do the same. And essentially, these are the ex ante policy evaluations you can do in this model. Now, this sounds all good, but without data, there are issues. So we're going to introduce now what is the data that will be used to calibrate this model. And what people use here is the famous SAM. So they put a nice name, right? So social accounting matrix. So the SAM essentially is a matrix that people built from national accounting figures, right? So you go to the Bank of Canada, they will give you all inputs to build a SAM. Some central banks already provide you the SAM, so they give you the social accounting matrix well done. In general, it is not done, and sometimes there are some consulting firms that sell you SAMs for several countries, right? So there are SAMs for Canada, for the US, for every country you want. Building a SAM is actually, you can do a living out of that. So building SAMs for countries and updating them year to year, that's something people do for a living, right? I work on that, for a period of my youth, right? So I think I have a year or 2 a year building a SAM for my country, right? and then, to the Latin American level. So social accounting metrics, is an art to build them. It's actually not that easy, but it's good to know econ. So if you really want to learn, econ properly, you should build at least one in your lifetime, a SAM. So, in particular, so I'm going to explain what is a SAM, a very basic one. So real life SAMs that are used for policy making, policy analysis, they tend to be super big. I'm going to explain how it works. So in particular, social accounting metric is a comprehensive economy-wide data framework, typically representing the economy of a country. A SAM is a square matrix S in which each account is represented by a row and a column. Each cell S sub ij represents the payments from account J to account I. So in other words, column J, which is a sector in the economy, will pay something to account I. So the payments comes from columns to rows, right? So essentially, this is describing the flow of money in an economy, okay? This is describing the flow of money in an economy. And the payments go from the direction J to I, okay? Now, I will explain with examples. So for instance, example, consumption is given by cells S37 for expenditure of household of type worker to commodities of the rural type. So essentially, so if you go to entry S37, right? So column 7, you can see here workers. And then entry 3 is commodities, rural, right? So you can see here an amount, okay? So this is a payment from households that happen to be workers to the rural sector in the side of commodities. So essentially, is a worker buying, lettuces, tomatoes, something like that. So this is a composite good, right? But they are buying essentially commodities from the rural sector, right? Agricultural goods, a composite commodity. So what is the name of this? This is the consumption of household in the rural sector. Now, workers also happen to buy commodities from the rural sector, from the urban sector. So you can think of this as the industry that we have modeled here. And this is the amount. Now, households are separated between workers and capitalists. So this is a status with respect to whether they own firms or they work. You can break them into many ways. In particular, this SAM is very simple. It's more a classical SAM, where also a little bit, with some tradition from Marxism, right? Separating households between workers and capitalists. But of course, modernly, the way we do it is usually by breaking them into percentiles of income, right? So we break households, for instance, between the poorest one in terms of income to you divide it, for instance, in 10 types of households, right? And then essentially you try to cover the distribution. There is always discretization with the types of households, right? And essentially how you, and I'm gonna use a word that is the key word here, how you open the SAM, you call this action opening the SAM. It means you can actually go into households, which is the category, and break it into many pieces that you want. So for instance, if you want to model a very complex tax scheme that is very non-linear across income levels, right? Which is, imagine in Canada, right? It's a progressive income tax. So you know that if someone earns about 25K a year, then they're going to start paying taxes, right? So you can form, for instance, households that earn from 0 to 25K. This is a household type 1. And then you start, using the tax scheme to essentially open the SAM in a particular way. So as I say, there is nothing fixed with this, but rather we know there is the household account, and then you can open it in whatever way you want. In this particular model, the opening is with workers and capitalists, right? The important thing here that I want you to understand is that this is the flow of the economy. So 7 pays to 3, 2.167. So there is some units here. We're going to imagine this is measured, for instance, in millions of dollars. So this is an aggregate account. So these workers are buying $2 million, right, of rural commodities, okay? The same thing here. So commodities here are open into rural and urban, meaning it's exactly agriculture and industry, which is not a great opening. So essentially, you can also open it in many ways. For instance, in one sense that I work, for instance, the commodities that you use were essentially, things such as food, transportation, recreation, gas, and so on, right? Clothing. So you can open it, as much as you want. So for instance, in some SAMs I work, we have 72 sectors or something like that. So you can have 72 commodities, right? And they can be very fine, especially for instance, the opening can be more fine if you are dealing with an ex-ante policy evaluation regarding sales taxes. So imagine if you're the Bank of Canada and you want to introduce a sales tax. And now, for instance, the sales tax is going to affect things such as recreation, but won't affect food, right? So then you need that level of definition, right? If you, for instance, want to tax certain foods because they have too many calories, then you have to open even more the SAM, right? So essentially, that's the policy question will define how the definition of the SAM. Now, so another example. So wages are given by cell S51. So let's go to column 5 and then look at row 1, right? So essentially here, you can see here that, so one second here. Right, so for instance, you can see here that there is a payment from factor. So this is actually wrong, this example is wrong. So wages should be exactly the payment from activities, right? To the factor labor, right? So I don't know why this is here. So let me change this. So wages, right, are the payment from activity, for instance, agricultural, right? So it could be S1, comma 5, right? So it was actually the transpose of the one I was mentioning, which is the payment, right? Is the flow of money from agriculture, for instance, to labor. So this is the wages paid by agriculture to workers. And then you can see that, for instance, wages from industry to labor would be the row S25, right? So this is essentially the payments to workers, wages. What are the rents? Whatever agriculture pays to capital and whatever industry pays to capital. And then the summation of these two cells will give you total wages. And the summation of these two things will give you total capital. Now, so if you go to national accounts, so if you go to Canada national accounts, they will have these figures. So they will have whatever, each sector in the economy will be earning from wages and what all the payments in rents from each sector of the economy. So each country varies in the level of definition that they have for each sector. At this level of aggregation, we have just industry and agriculture. In real life services, when you go to a central bank, you can have very fine sectors. So remember that there is usually this industry code, right? That essentially each country generates to classify the different industries or sectors in an economy, right? So the level of definition of that industry code essentially is the one that gives you the national accounts. Okay, so, and then you can essentially keep studying the other one. So for instance, one that is very important here is our imports. So imports are cell 9.3. So this is rest of the world, right? ROW. So in fact, let's do it like this, rest of the world. And then the payment of this to account 3, right, is essentially what the rest of the world is buying from rural, right? So, and then essentially you can have the opposite, right? So remember, payments are here are from columns to rows. Now, important thing about the SAM. So when you go, and this is a square matrix, right? All the flows in this economy must be balanced. So supply is equal to demand, market clearing. So let's check, for instance, all the payments from factors 1 to 9, right, to the activity agriculture. So if you add to everything, this gives you 2.2. Now, when you check now all the payments of 1 to all sectors, right, then it must also be 2.206, right? Essentially, this is supply equals demand, right? So what it means is, all payments received by all agents in the economy to agriculture must be equal to all the payments that agriculture does to all other sectors, right? So this is the circular flow of the economy, right? So essentially, all payments received must equal to all payments made, okay? So this is a full model, right? And then you can check this account by account, and you can see that this must match. So essentially, This is called balancing the sum. And essentially you go, checking the national accounts. And when you do an opening, for instance, between households and capitalists, then you have to be careful that your matrix remains balanced, right? And essentially, that's part of building the sum. When you build these entries and you add them up, using Excel, for instance, then you have to be careful that every row is equal to every column at the total level, okay? And this is essentially because economy is, in this case, is a circular flow, and everything must remain close. Any questions here about the sum? So essentially, say that you're lucky and someone did this for you. You're gonna receive a sum as an input, right? They give you a big spreadsheet with all the sums that they're gonna use, and then you, the analyst, the modeler, you will use the previous model to calibrate your parameters to match this sum, okay? This is what you want to do, okay? Now, you can see that this gets really complex really fast. This is a very, very simple textbook-like economy, right? We have two sectors, it's a small open economy, nothing fancy. And the sum is already getting a bit big, right? It's not small. Now, imagine one where I have 10 households, I have 76 sectors, and then I also break capital factors like labor into levels of skill, like human capital, right? And capital by other things. I add more factors than just labor and capital. So then this thing becomes quite large very quickly, right? So building this, is a full-time job. And then calibrating this is what people get paid for, right? So essentially, calibrating a sum to a particular model is what people get paid for, okay? Now, so this is all cool. I think it's a nice effort. So, we keep improving, but there are some issues here. So the first issue, essentially, more than the sum is an accounting tool. So that's just a nice thing to have. It's good to understand the economy. I don't have any critique about the sum. The issue about the sum is that this provides essentially, one outcome of one run of the economy. So as you can see, you can think of this whole thing a description of an economy, but it's no more than one data point of the economy. So that's the tricky thing. So essentially, this provides a static picture of an economy in a given time period, right? So essentially, this will be an annual summary of aggregate outcomes of a given economy. A typical sum will represent the flows of payments and of an economy in a given year. Okay, so essentially, this is a static picture. So in that sense, this is just one big data point, but it's only one data point. And then essentially, what we're doing is we fix a very parameterized model to this one data point. So
Victor, one question. So
yeah.
Is it common to get this level of disaggregation of data for every country? Because, for example, for Argentina, I cannot imagine at all having like this level of disaggregation. It's
no, I mean,
crazy.
So, well, Argentina right now has some issues with national accounting, right? Because of some politicians, right? Ecuador is a middle-income country. When I worked this 10 years ago, I was able to open this into 76 sectors. So it's not crazy. When you have countries like the US, you can have really, really fine, sums that can have up to hundreds of sectors, even more than that. So yeah, so essentially, for instance, if you go to national accounting in the US, which are more, acquainted than to Canada, it can be super, super fine. And especially if you do openings with respect to spatial variables, like for instance, the states or counties, right? Counties. So this is actually, you can get a lot of definition. But, so essentially, it depends on your question. So if you're doing policy evaluation, right, that is really focusing on changing tariffs at a very fine sector level, then you did not need to open the economy at that level, right? Now, in order to build a sum, you can run surveys, you can get your own data. So that's part of what people do. And so building a sum is an art. I'm not gonna get into it because that's more an empirical thing, but it's really fun, right? For instance, you have to use surveys, household surveys, firms surveys. You have to use census. You have to, so for instance, in order to build a sum for my country, I used the household survey that we had, the labor survey, the industry survey, the national census, the national agricultural census. So you use all data possible, and then you use all the exports data. So the tariffs data, right? So you use basically all possible sources of data that your country has. And building this is essentially a summary of the economy, so it's really fun to build. Now, sometimes some countries provide them, and then now some consulting firms sell it to you. So they have a specialist in each country that do this job. So, but right now we're going to imagine that you are given the SAM, right? So you're the high level consulting guy that, paid some local guy like me at the time, right? to do the SAM for you. And then you come and with a fancy model and you want to calibrate it, okay? So that's what we're going to imagine now. So essentially, first of all, Ival will be a consumer of these models, if you are the policymaker, and then some consulting guy comes from another country and tells you, I want to sell you a general equilibrium model. This will answer all your questions, right? Then what would you ask? So first of all, I will ask, why in the world do you have this equation for production, right? So what is the rationale behind it? So can you answer this for me? So in particular, the main issue with these kind of models is that they don't come from any analysis of an economy. So they don't come from a deep knowledge of the particular country. So they come because of computational advantage. So this famous CET has very nice mathematical properties that will allow it to be a very well-behaved equation in the nonlinear system of equations you are proposing. The same thing with the Cobb-Douglas, right? So all of these are chosen because of simplicity. So this is a big caveat of these models. And essentially, these parametric forms are chosen because of computational feasibility. And a little bit the game is that you want to add as many, as little as flexibility as possible in order you want to have the smallest model in order to match the SAM. Now, how do you match the SAM? So remember what is data now and what are parameters. For instance, you remember that we have payments, right? Like production. We know also consumption. We know imports. We know income. We know prices. We know so wages, right? What we don't know is, for instance, the raw parameter of the production function, the sigma parameter of the labor substitution. We don't know the shift parameter. We don't know the CES alpha. We don't know essentially these parameters of behavior. So the role of this calibration of the model is going to be to use the data, the outcomes of the economy, to match these particular parameters, and this is called calibration. Okay, so let's go back. Let's use a simple example of calibration, so you have an idea. This is the easiest one, right? So let's do a calibration here. So usually here in this stage, I used to add a little programming demo where you could do the calibration in GAMS, which is the language all these consulting guys use. But then, it's a little bit lost on the students because for you, I just run the program I did, and then I don't have the time to go line by line. So I'm gonna do it more theoretical this time. So calibration of the parameter of the utility function. This is the easiest one. Other calibrations are harder to make. So in general, remember that here we observe consumption, right? So we observe how much households are consuming of each eye. So where do you find this? You go to the SAM, and remember that, for instance, if we fix sector this to agricultural sector, right? Or we're calling them rural, in fact, right? And then these are for households, the workers, right? And now what is this equal to? So remember that we went to the SAM and we saw that this was 2.167, right? Now, what is the income of the workers? Okay, so how do you find it? So remember that these are the payments, right? So households, you can see here, what are all the payments they receive, right? So you can see here, for instance, they have bought, so you can see from the side of expenditure, right? And you can see this is the total expenditure, which has to be equal to the total income, right? So you can also go here, right? And see how much workers receive as part of factors, right? these are payments to labor, right? And this is from the side of income. So income is equal to expenditure here, is a complete closed economy. So this is 2.899, okay? So this is the income of workers. Now, what are the prices? So prices, this usually you have to get it as an outcome of the general equilibrium, right? But for instance, at this stage, you can do an initialization using data from the CPI. So this you have to use some external data from CPI stats, right? StatScan, for instance. And then here you basically fix the price of the rural goods to whatever, to whatever you found. So in this case, is 1. Now, how do you find the beta of workers of rural goods? Well, you just divide, right? So this is going to be equal to Q divided by YH. Remember, PI is 1, so I just removing it from the equation. So this is this division between these two things, right? And then someone can compute it using a calculator. Yeah, and the income is 2.889. Okay, so this will give you a value, and this is the beta. Okay, so this is one of the simplest way to calibrate. This is a Cobb-Douglas, and you're calibrating the shares. Okay, and that's why people choose Cobb-Douglas many times, because it's so simple to calibrate, right? It's just a division. Okay, and then you get your beta. Now you have many other parameters and many other entries in the sum. So essentially, you have to keep moving these parameters until given the prices that are solved endogenously in the equations that I gave you before, because this general equilibrium, prices are endogenous. Then this will essentially reproduce the sum. Okay, so it's not easy, obviously. It's a lot of work. That's why people get paid for it. So essentially, you have to go equation by equation, entry by entry of the sum, and then find out all the parameters you need. So remember, what are the parameters? So the parameters here are rho, sigma, the price of the world, the shift, alpha I, and exchange rate can be also a data point. But so all of these you have to calibrate or find data for it. So when you do that, essentially you reproduce the sum, and then the next step is you can do counterfactuals, right? So in general, calibration entails finding values of the parameters of the model that deliver outcomes of the economy that matches the sum. Okay? And then essentially, for example, for the shares of the Cobb-Douglas, for the consumer demand function, we can do the following. Okay? And, this process, can get very lengthy, but once you have done it, you have obtained a calibrated model. So the result of this calibration is essentially a model of general equilibrium that, when solved, finding the prices, given the parameters and the allocations, it will match the sum. Okay, so once you have done it, the next step obviously is to do the counterfactual evaluation, right? So in this part, the counterfactuals of the CG, then you modify one equation in the system. For instance, say I want to add a tariff. So you go essentially to the equation regarding the price of the world. And then you change it, right? So here, you're also adding a tariff here, TI. And now this TI becomes a new parameter. Evidently, at baseline here, tariff is equal to 0. So the baseline is a free trade economy. And then you can evaluate the counterfactual effects of changing the tariff. For instance, you can say now tariff counterfactual situation is equal to 10%, right? So you can, of course, here it's written as a proportion. So for instance, one easier way to do it would be as a product. So I don't have to write a baseline, right? So you can just do it as a 10% change, right? And that's it. Now, so essentially that's what you do. So nothing fancy here. So essentially you change the baseline equations of the calibrated model to match the policy that you are trying to implement. Examples of policies are tariffs changes, income taxes, sales taxes, subsidies to industries, right? And essentially those are the main ones, okay, that people use in these ex-ante policy evaluations. I'm forgetting this, cash transfers. Universal basic income, for instance, UBI, all of that can be modeled here, okay? Okay, so this tool seems to be useful. People use it a lot, but again, I make some points criticizing it before. The main issue that we have here is essentially that this model does not have really any strong theoretical backing of why we should use these particular parametric functions. And the second issue is the calibration. So essentially you have a big data point, which is the sum, and then you use just these data points to essentially match these shared parameters. So in general, you see that this is a bit of an issue because, for instance, imagine these national accounts have measurement error, right? As it can happen. Then your shares are going to also be bad, right? When you do counterfactuals, these counterfactuals will have measurement error there, and then we'll produce counterfactuals that are bad quality. So in general, so what is the best way to bypass this? So essentially, you know, one important open question that nobody has tackled, as I said before, is how to develop a similar tool that allows you to these counterfactual questions that are very important, ex-ante policy evaluation, like free trade agreements, using only the shape constraints such as convexity of the production function or concavity of the utility function, but without being parametric. So is there a way to just use shape constraints and be able to match it to data, right? Other things such as the lack of data are things that we can improve upon. For instance, originally, Martin made a good question. So how feasible is to have these sums, you know, very disaggregate level? So that's very feasible now. The main issue is that you just have one sum. So the ideal situation will be one where, for instance, you have a collection of sums, right? Like, for instance, you have many sums, you know, for many years, or sums, monthly sums, for instance, right? You have great national accounting, right? Like Sweden. So you can do monthly sums. And then essentially with monthly sums, then you can fit, you know, using some regression techniques, a model of general equilibrium to the time series of sums, right? And that's essentially, you know, each sum is a new draw of the economy, and then you can actually think of that. So think of a sum as a cross section. So if you see it in time, you're seeing a panel of data. So
Victor, one question.
Yeah.
That does the length of the time period that you're taking into account change as well?
Yeah, so you choose as a modeler, you have to choose the length period. So for instance, typically a sum will cover a period of 1 year.
But that depends on the availability of data, right?
Yeah, like for instance, that's what I was telling you. Like for instance, right now, for instance, consumption data usually is very expensive to get. But countries like so for instance, most countries measure it, even rich countries measure it in quarters. So you have every quarter you get a new survey, right? Labor service instead, because unemployment is so important, usually are done monthly and sometimes even, you know, bi-weekly. In other places they do it weekly, right? So depends on the country, but labor service, you know, for measuring wages and labor supply, usually those are plenty. So you have many of them, so a lot of time periods. So right now, for instance, sometimes you don't need, for instance, in the administrative data, sometimes you don't need service. You can track, for instance, the changes in consumption of people. Like for instance, if you're Amazon, you will have, daily data of consumption, right? But of course, when you are the government, you won't have as often. So right now, data is changing so fast that, I think you can build, more disaggregated, more frequent SAMs. But, previously it was a big event to build a SAM for a country, right? So for instance, building a SAM for Ecuador, it took, it was me and one friend, we built it for a year, right? And, that was essentially what happened in other countries. You have, a team building a SAM for one country, and that covered a year period. And that was, a big event because you had to collect all sources of information available, right? Now, I think it's much easier to do it, and you can automatize a lot of the process, right? So yeah, but this is a little bit of the challenge here. So building the SAM is a big deal, but that's empirics. I think the challenge for you as students of a PhD, more than building a good SAM, which is fun, but just that's the input, is actually building a better model of general equilibrium. But what I wanted to display here is that there is a need and a demand, right, from policymakers and people out there for models that can allow you to predict ex ante what is going to be the effect of a policy, right? And remember, these questions are super, super present, right? For instance, governments will make changes that there are no data about, right? For instance, imagine a UBI. So you can run a small experiment, that's great, yes. But what's gonna happen if you do it at a large scale, right? So then you need models. Now, of course, calibrating or estimating these models in a better way using better data is the first step, but also removing these parametric forms is also an important question that we need, or at least justifying them in a better way. So why do we use these particular parametric forms? Just because, I learned it in a book and I can apply them for all industries in all countries in the same template? Well, I doubt that is actually something useful, right? So these are things we have to know, right? As users or possible future producers of these models. This is a bit of an issue. Yeah, questions here?
Yeah, Victor. So when you talk about building a better general equilibrium model, you are talking specifically about what we saw the last lecture about using the African inequality so as to not depend on the parameters of the model and reduce like the dimensionality.
Yeah, exactly. So for instance, imagine that you just use, instead of having this parametric demand of Cobb-Douglas, right? You just assume all consumers here are affluent maximizers, right? So utility maximizers and hence subject to affluent inequalities. Can you replace this by this type of affluent inequalities questions, right? Now, I'm not claiming it's the only way. For instance, some of you may study machine learning, learn non-parametric techniques of econometrics, and then replace, most of these equations with actually data back functions, right? And then you can plug them inside a system, right? So all of these, are things that are widely open. So essentially, what I'm giving you is the state of the art, what people use right now. And what I wanted to highlight with this class, which is not even going to the exam, but it's important for you to really, build the big picture of general equilibrium. So we learn, in following Mascolel, a very abstract version of general equilibrium, right? So we learn existence, we learn the local uniqueness, sufficient conditions for uniqueness, first welfare theorem, second welfare theorem, properties of this. None of these topics told you how to use general equilibrium in real life, right? So when you go, you're hired by someone, then you're basically thrown to your face these things. And they say, look, here is a problem. We want to raise tariffs with this country, right? With Canada, you're Trump, a Trump employee, not supporter, is different, right? So we're workers, right? And then essentially, you are hired to do a policy evaluation, right? They want to raise tariffs to the Canadians. Now, how do you do it? Well, I'll tell you how people do it now, right? So obviously, this seems to be the low-hanging fruit. So you parameterize, Once you have parameterized, you can calibrate these parameters. And then once you have matched the data in some reasonable way, you can do counterfactuals. Now, the question is, can we instead replace, these parametric forms that are super arbitrary? And essentially what I mean by arbitrary is this. So imagine, for instance, that I have this same sum. I don't change the sum, so the data remains the same. I go to the consumer demand, right? And now instead of having this demand, I add a new parameter, right? This is a new model of demand, right? I have a new parameter. It's a different behavior. What will happen with this model now? So will this produce a different counterfactual when I change my tariffs? For sure, right? As long as omega is not 1. So the issues, and I'm sure this model is being more flexible than the previous one, can also be matched to the sum, right? And for instance, essentially, if I force myself so omega is not 1, then I can have different calibration of the whole rest of parameters. So essentially, there is no way to really validate this such that I'm sure that my calibration makes some sense empirically. So it's a pure exercise of reverse engineering, okay? So again, why people accept this and why people buy this? Remember that in the end, there is this need of policymakers to get some answer. So some people argue that this is better than just arguing in the air, right? That say, look, if you do cash transfers, universal basic income, everyone's gonna be happy, right? That could be the answer of some social scientist that is not an economist, right? So this is great. Now, what does it mean great? Right? Now, how much is gonna cost us? How much is gonna benefit people? What are gonna be the effects on other sectors? Maybe giving everyone a lot of money will cause inflation, and then inflation will reduce, the purchasing power of other sectors. So, maybe if I, give too much money in the economy, then people are going to start importing more. Okay, if you import more, that's how's going to change other sectors, right? So essentially, what I'm saying is that when you change something in the economy, it's going to have widespread implications. That's the general equilibrium idea, right? The butterfly effect. So some small changes in some sectors, some big changes in one sector can change very far away sectors in deep ways. How do you quantify that? It's hard, right? So at least having equations per sector could give you a hint. That's the hope, right? So that's why people keep buying these things, right? And then there is a market for people building these models, right? So they try to quantify these forces at play, How a human brain, think of a policymaker, right? So you become the head of the Bank of Canada. And then you're told, that you have to implement a tariff, right? A new tariff. Then how can you have in your brain all the implications for the hundreds of sectors in the Canadian economy? Is there a feasible way your brain alone, without the help of a model, can do it? Very hard, right? So a little bit the discipline of building a model, right? Writing equations, even if a bit arbitrary, and then actually thinking of the sum with the 76 sectors, right? And thinking of the flow of payments, right? Sector by sector gives you some discipline to the policy analysis. And that's why they have some value. But now the issues, of course, is that the parametrization is completely arbitrary, right? So there are many possible configurations of parametrizations that will fit the sum. As I said, if I change the parameters here in the consumer demand, then all my parameters will change. So the issue is that you can fall in the trap that you are introducing hidden assumptions in the parametrization of your model, right? That will capture biases, right? For instance, you say, poor people, they like to match, leisure and consumption goods such as, potatoes, right? So I'm going to calibrate, the share as super high for poor people, right? And then savers, capitalists, they like, they are Spartans, they like to save, they don't consume much, right? I can introduce that in this thing and match it, right? But maybe does not correspond to reality, right? It can be very sumptuary expenditures from the capitalists, right? So essentially, and that's the issue with macro. So a lot of the history of macro was two guys having two different models of the same economy, matching the same data of the national accounting, but with different stories. And then, each of them have different counterfactual implications for sure. How do you know which one is true? Now, this takes us back to the previous chapter. What are the empirical implications of general equilibrium, right? And now we know them. We know that in order to have general implications of general equilibrium, you have to have variation in endowments or variation in markets, right? Market variation. So you need to have some sort of panel data, spatial data, variation in time with changes in endowments. And then essentially, you need to use, then you are sure that general equilibrium has testable implications. So essentially, if you have two competing models, then you will have to test it with the data, with respect to the data you have. And if your model passes, right, is not rejected, then at least you have a claim to glory, right? And then if your model rejects your story, then you're done, right? So now have you seen many people in macro testing their models? Not really, right? So what they do usually, which is a sub-form of testing, is what they call matching untargeted moments. So essentially, when you do a calibration, sometimes you leave certain outcomes of the sum untargeted. So you don't calibrate the parameters with respect to those entries. And then once you solve the model, you compare it with the untargeted entries of the sum. And then if you're close enough, your claim is that your model is a good description of reality because these entries in the sum that you didn't target in the calibration, you still are able to match very closely, okay? So that's a little bit the idea that people do in macro, and that's the best they have done so far. Now, is there room for improvement? Huge room for improvement. So a lot of the critiques to macro are essentially in this part. So essentially arbitrary calibration of parameters, lack of arguments of identification. So what do we know about the parameters? Can we really point identify them as I obtain the share with this simple division? This seems too simple to be actually useful, right? And I really doubt is a good way to calibrate this, right? So in particular, can you use something weaker? Can we at least provide a set of all parameters of the share of the Cobb-Douglas that matches the sum? Do you understand? So in particular, all possible parameters beta that matches the sum, that will be a step forward, right? Now you have a set identification of the beta. So all of these things, are possible improvements in the current macro state of the art, okay? So, but one thing I'm gonna tell you, we are gonna be doing structural models forever. It's very hard to do without them, okay? There are many things we can never run an experiment, or even running an experiment, there is a lot of doubts whether or not these are, externally valid. For instance, imagine, as I mentioned, right, the typical question of tariffs. So can you run an experiment using tariffs? So for instance, I can say, look, out of all countries in the world, Canada is gonna put tariffs to all countries that are, if you number them from 1 to 100, I'm gonna put tariffs only to the odd ones. And then, no tariffs for the even ones, right? If I'm free to do that as Canada, that would be a great way to know whether tariffs changes your economy in different ways, right? Because if you put, a tariff to plastics to all countries that are even number, right? And then no tariff for the others, then you can measure effects. Can you do that sort of experiment in tariffs? You cannot do it, right? Canada is basically a subscriber of a lot of international World Trade Organization, agreements that basically forbid them to treat unfairly to different countries, right? You cannot discriminate. There is a principle of no discrimination in international trade, right? So essentially, you are just, maybe you can argue it's not discrimination, and then someone is going to say, you signed a free trade agreement with me. You cannot now put a tariff to me, right? So they will sue you, and they can possibly win. So essentially, changing tariffs in very random ways is almost impossible. So that's why international trade is essentially, the main example of doing this thing in real life. The other example is cash transfers. So, you may argue, that cash transfers are easy to run experiments, and people have done it. But at the same time, you don't know exactly what kind of cash transfer are more effective, right? And if given too many of them, for instance, what amount should I dedicate to cash transfers? Will they change the economy at large? So one key example of successful structural modeling is in Mexico, right? So Mexico has one of the most successful stories with the cash transfer program called Progresa originally. Progresa means to progress, right, in Spanish. And then oportunidades, which means opportunities, right? So they changed the name from progress to opportunities because, it's a little bit better in terms of human capital. So what they did is essentially they start giving money directly to poor people. So instead of, for instance, increasing minimum wage, they just target people that were below the poverty line, and they send them a check, right? Directly, right? To a bank account, or they can go to an ATM and get their money, right? Using a national ID number. And then essentially, so if you were identified as being poor, you receive an amount of money, right? Now, in order to do that, it's very hard to decide how much money should they give them. Should we give them money according to a condition? So, or should we give them without conditions? Like the condition was you should take your kids to school. So they shouldn't mismatch school. If they miss too much school, then you are in peril of losing the cash transfer, right? You should take your kids to the doctor. If they don't go at least once monthly, then you are in danger of losing the cash transfer. Now, all of that, you can design, you can run experiments, and people did run experiments. But at the same time, you were giving money, to millions of people in Mexico. That's going to change the economy. That's going to change prices, right? That's going to change the prices locally, right? So also people were scared that people may stop working, right? So shortage of labor. So how do we know what is the correct amount to not have loss of working people, right? So they essentially ran a lot of structural models that were very well calibrated with a lot of data from a lot of surveys, so not calibration like this one that I did here, but serious estimation of parameters. And they were able to predict a lot of outcomes that then were matched in reality by experimental validation, right? And essentially, the Progress and Oportunidades was an example of very well-designed ex-ante policy that then, was matched by ex-post experimental evaluation. So it is possible to do it, yes, but you need high-quality data, you need transparent governments, and you need, high-quality modelers. And in particular, we economists have a lot of experience modeling consumption. So this example I gave you of the Cobb Douglas is a bad example, but people in developing worlds, they have worked a lot of years since the work of Deaton, right? Nobel Prize winner on consumption. And then people have a really good idea of how people consume different, essentially, food and other basic goods. Yeah.
Professor, just a question. I didn't hear that clearly. Did you mean Angus Deaton?
Yeah, so Angus Deaton, so he, started, as I told you previously, with almost ideal demand system. So very early in the 70s. So since then, people have been collecting surveys on consumption data, right? And we have been modeling this. So there has many, many decades of experience of economists modeling consumption, right? So when you deal with cash transfer, essentially you're modeling consumption and labor behavior. So these are the two subjects that have been studied the most, right? So how people respond, so labor elasticities and consumption elasticities. So these are the things that we know the most, right? So I think that helped a lot in understanding the cash transfers in the Progress Oportunidades example, right? But what I wanted to tell you by this is there's always going to be the possibility of doing new policies that are very hard to just run experiments. So you need a structural models. Now, are the structural models perfect? Not at all, right? So they may fail in a terrible way, right? In particular, they depend heavily on these parameters. And if you don't know deeply the economy, you may fail by a lot, right? Also, macroeconomists tend to sin on the side of being too precise. So they provide this, they don't provide safe set predictions. So they just choose a scenario which they think is better from their model. So they use the discipline of the model, but then among the predictions of the model, they pick their preferred story, right? So in that sense, they are not fully transparent. And of course, there are lots of rooms of improvement for this. And then I'm going to stop there. But essentially, I wanted to give you this overview of how people do in real life general equilibrium, right? And essentially, this is a tool that everyone uses because it's so important. And I wanted to also highlight with that the importance of general equilibrium thinking. So essentially that one change in one sector of the economy could have far-reaching effects on far away sectors, right? So essentially, the economy is an interconnected system and it's a very complex system. And hence, thinking as an economist requires that level of general equilibrium thinking, right? So you cannot have this isolated analysis, right? You have to always think of the further implications of this. Now, most brains cannot do this properly. So we need models, right? We need a way to try to discipline our intuition by modeling sectorial changes, right? Means of equations. Now, do we need parametric equations? That's the question, right? So sometimes they happen to be successful, as in the case of consumption, just because economists have many years of training trying to fit, consumption data. But sometimes it's harder. And then essentially, is there a space for non-parametric approaches, right? And can we do something about the data as well? Can we improve the data that fits our general equilibrium models? But yeah, that's the challenge, essentially. So very few people are working on how to do empirical analysis of general equilibrium. in real life. So this is an open question that everyone knows is important, but nobody has done it because it's super hard. So any one of you that decides to do in the second year tackle this, difficult question, it's gonna get a lot of attention if you're successful. Else you will be remembered as a brave student. No, just kidding. But this is risky. It's not that people haven't thought about it. Daron Ashemoglu, he has a paper talking about how doing this reduced form analysis a la stir to flow, right? Thinking about average treatment effects doesn't work in general equilibrium thinking, right? So a lot of the reduced form analysis, especially average treatment effect, which is the key object of interest in reduced form literature, is assuming partial equilibrium. So it's assuming that the market you're studying is isolated from the broader effects of the general equilibrium. This is obviously an issue, and then people have thought about it and then knows that the typical reduced form analysis fail. But how can we go away from it, right? And from the side of macros, so as I told you, most people are discontent with macro empirical analysis, the classical ones, because of this issue with calibration. So how do we know that the parameters you're getting mean something, right? And how do we know the impact of a choice of a parameter in the counterfactual prediction, right? So how, in other words, why should I believe the particular story you are telling me among hundreds of other stories, maybe a continuum of other stories? Can someone provide me a nice sensitivity analysis of all possible parameters that matches the data, right? And all possible counterfactual predictions that matches the data in the model? Or can someone go even further and produce a non-parametric analysis of general equilibrium, right? So these are open questions there that will improve a lot economics and policymaking ex ante analysis. So, these are challenges for young students like you. So I just wanted to leave it up there, okay? But this was a good way to match, theory that we did, very abstract theory, right? With the practice of general equilibrium, right? Which is, very hands. And as you can see, a lot of witchcraft, right? But, people need it. And then, we're workers, so we provide. And, you have two hats. The consulting hat, the empirical guy hat, and the theorist hat, right? The theorist hat is kind of the Pope's hat, right? So we're super pure. We don't like to make assumptions about anything. We don't get our hands dirty, right? You're an empirist, you get hands dirty preparing the data. So you produce a nice, shiny SAM. Nobody is going to ask you the details, right? You have to be a serious, honest guy to produce things that people actually can use, right? But there's a lot of there is fraud in empirical analysis, right? You have to be part of the solution, not of the problem. So you have to do serious work there, but you have to get your hands there. You have to make choices. You have to, choose sources. You have to fix, improve data, clean data. All of that requires decisions that are not fully pure, right? So that's why a lot of theories don't look with a good eyes to the empirical guy, right? So you have to get your hands there. And then finally, there is the consulting guy hat, right? Which is a guy that wants to make money, right? And then math, econ, and then you sit down and you provide an answer to the guy that hires you to the best possible of your capabilities, knowing that it's not fully scientific, but you are asked to provide a question and you provide the best you can. So this obviously is a partial answer with certain degree of uncertainty whether it is correct, and but people require this, and they will be possibly better, worse off without it. And that's a little bit the justification that suits your soul, right, at night. So that without these models, they may be worse off. But again, you have to separate it. So for instance, I will never pass a consulting output using these models with arbitrary questions as a scientific output, right? And that's what people actually miss, and you have to separate these things, right? If a macro guy answers some question with a calibrated model because it's important, it doesn't mean that the model is correct or it should be scientifically valid, right? So we have to separate. There are needs from policymaking that will be met by someone, and the better someone is capable, right? Like an economist, a macroeconomist. But this, I won't call it science. There are a lot of issues there. Nobody's testing models, right? Nobody's providing the empirical implications there. Nobody's checking, the soundness of out of sample validation of your model. So if that's not happening, it's not science, right? So there is a lot of room for improvement, especially trying to mind the gap between policymaking and science, right? We're still far away. So from that, but you are just in the joint of is two words, right? When we have more data, we have better computers, and we have better theory. So you should be able to do something, I hope, right? Okay, so I'm gonna take a break for 5 minutes. Yeah,
I had a small question. So just why did Darren ask you